So this discussion is going to be a two-part discussion on the science of aging. Now, different people are thinking about this in different elements in their life in this room. Some people don't think about it at all. You will. Some people are thinking about it some people are thinking about it a lot. But I wanted Nir, who is really the international authority on the science of aging, to come give us 10 to 12 minutes on current thoughts on the science of aging. And then we're going to have a panel discussion with two incredible people who are kind of defying what you might think about in this discussion. Nir, take it away, my friend.
Terrific. Thanks.
Exactly. No, go right ahead.
First of all, can you hear me? It's much easier to stop aging than to treat cancer. Much, much easier. And I hope you'll remember it by the end of the talk and you'll realize that. Of course, if I have a cancer, this idea that I have to find a nurse whose name is Nir is very discouraging for me. I also learned today that when I go to the OR for my cancer, I need to go without a groaning. And this thing of tongue in the ear is really shocking to me. So thank you. I've learned a lot. And to bring you to my world, let me tell you this story. I actually invented this story for Jordan. There are lots of centenarians, 100 years old in Japan. And a reporter tried to get to the story of why they survived so long. So he went to this 100-year-old and he said, what's the story? And the guy said, I think it's because I'm running. I'm doing the marathon, I'm running here, I'm running that. And the reporter said, this is really great. Maybe that's the story. And the centenarian says, by the way, I have to run now because I'm meeting my father. He says, how old is your father? Says he's 125. And tell me, what about him? Is he running? He said, yeah, he's running all the time. We're running the marathon together and that. And he said, well, I'm really up to something. And where are you running? They said, we're running to see my grandfather. He said, well, how old is your grandfather? He said, he's 150. He said, and is he running? He said, no, he hates running. Never ran in his life.
Guys, I just have a quick announcement. If there's an empty seat next to you, raise your hand. Everybody in the back, come fill in. Keep your hand in the air. 1 or 2 seats because we're going to not let anybody else in. We're totally filled to capacity. So please keep your hands in the air. Everybody standing in the back, please come sit down because otherwise they're going to shut the doors on us in the back. All right, that's advanced. You got it right there.
Okay.
Good?
Yeah. So what am I going to tell you? I'm going to tell you that aging has a biology, and I think you know that. When people get old, your grandparents, your parents. But the point is that not only aging has a biology, but because it has a biology, it can be targeted. And also to realize that, it'll be nice to stop aging, but it's not only for old people, it's actually for people who are surviving cancer. They are, from a disease perspective, 10 years older than their age. People with HIV are 10 years older than their age from an age-related disease perspective. If you want to go to Mars, you're not going to get to Mars if we're not going to have drugs that will protect you from the effect of aging or you'll get cancer on the way there. So think of it not only as aging. By the way, people who are on wheelchairs, who cannot move, they also are aging. They get obese, they get diabetes more than anywhere else. So please don't understand me as saying this is only about aging. But the thing we learned about aging, so this is the Khan family whose, there are 4 siblings who were born in New York between 1910 and 1920 to 2 parents. It's the 4 siblings. And the interesting thing is all of them got to over the age of 100. This is 100, 110, 102, 107, and 109. What are the chances? Not only that, those guys and our centenarians, they don't exercise regularly. They are obese or overweight, 50%. 60% of them are heavy smokers. So there's nothing with the environment. In fact, it's in spite of their environment. So this woman here, Helen, she celebrated over 90 years of 2 packs of cigarette smoking. And it's true, if you smoke for 90 years, you live long life. But the point here is those people were protected from the effect of the environment. So what really they had was genetics. Now, aging is the major risk for all those diseases that we're afraid of heart disease, of cancer, of diabetes, of Alzheimer's. And the relationship between death and age is logarithmic. So the risk of cancer when you go up age is between 5 and 5,000. It's a 1,000-fold risk. And when we entered the field of biology, we said, you know what? If aging really drives the disease, the only thing we could do is target aging, because if we're going to be successful only with one thing, that we're going to exchange this thing for another disease. You know, we're doing well with heart attacks, right? If you go to the emergency room with a heart attack, you get a stent or a bypass, and what happens to those people? 2-3 years later, they get diabetes or cancer or Alzheimer, because we never stop the aging prospect. And so aging is the driver of the disease, and we know a lot about aging, and there are the hallmarks of aging that I'm not going to go into because I didn't realize I have 10 minutes, but two things I will tell you: that healthy lifespan, and I'm not talking about lifespan only, but healthy lifespan has been extended in numerous models by numerous of methods. So nematodes and flies and mice and rats and monkeys with genetic alteration, with drugs, with effects on the environment. And some of those drugs are actually in human use, except they're not used in order to target aging. And this slide was going to give you some idea of some of the drugs that were being tested by the government that came from labs and actually showed that there is a survival benefit for mice that are taking those drugs, suggesting that it might apply to humans too. But back to the centenarians. One of the questions for us is not the fact that they lived long, but did they live healthy? Because if they got sick when everybody got sick, and then they were 30 years, 40 years sick, it doesn't serve any really good purpose. So you see here results from two studies. One is New England Centenarian Studies, and one is our study. Our study is in green and blue. So those are people without longevity, and they start getting sick at about age 60. And at age 80, 90% of them have some form of disease. One of those diseases, only 10% don't have a disease then. On the other hand, the centenarians are living healthier much longer, and even at age 100, 30% still don't have a disease. They don't take any drug, and many of them just don't wake up one day. And this really is not the important thing. The important thing is that they have a contraction of morbidity. In other words, they are sick much less at the end of their life. And the CDC out of Atlanta, the Center for Disease Control, actually have shown that when they looked at the 2 last years of life, the medical cost in the last 2 years of life of somebody who died over 100 versus those who died when they were 70, it was third the cost. So we have confirmation, economical confirmation, that living healthier longer and contracting morbidity is of an economical benefit that we call the longevity dividend. Actually, there are papers that have calculated how many trillions of dollars it will add even if we'd live healthy for 2-3 years more. It's like $7 trillion to the economy. So remember, we're not talking about longevity, we're talking about health span and the ability to change that. Now, I'll tell you briefly, and I'll close here, the challenges. The challenge for us is that the biologists find mechanism. The biotech and pharmaceuticals are using this mechanism to develop drugs, and they're targeting drugs for diseases. This is the case for cholesterol and for hypertension and for diabetes. And in fact, they come back to the scientists and said, find other mechanisms, let's develop combination drugs, better drugs, And this goes very well. The problem with aging is that aging is not an FDA indication. And by the way, we don't want aging to be an FDA indication because there's ageism, but we want something that will be an indication. If there's no indication, healthcare providers don't have to pay their customers. And if healthcare providers don't pay their customers, then pharmaceuticals are not going to come in because they need a business plan. And the way we, and I'm saying we, our bunch of scientists are dealing with it now is the following. There is a drug that is for treatment of type 2 diabetes. It's called metformin. Metformin has some anti-diabetic properties, but it's really amazing action is that when you give it to all animals, they live healthy and they live longer. It's a generic drug. It's one of the cheapest drugs out there, 600 tablets for $40. There's a 60-year experience with metformin with outstanding safety data. Now, people who are, this is a study that was done on 200,000 people looking at their mortality. People in metformin that have diabetes and are more obese and more sick have less mortality than people who don't have diabetes, and of course, much less mortality than people who have diabetes and who don't take metformin. But metformin has many other qualities. It decreases heart disease by 30%, cancer by 30%, Alzheimer by 30%. In other words, it really attacks aging. And those are what I just said now. So we have a study that's called TAME. It's headed by the American Federation of Aging Research, and the study had one thing is to prove the concept that we really can target aging. But I wouldn't lead this study if it wasn't working with the FDA in order to get indication. And we figured out what indication we're going to do in order to do this study. And just to tell you that this study is taking 65 to 80 years old, 3,000 people, and randomizing them to metformin and placebo, and look at the time to incidence of several diseases of aging together. We don't care which disease we're going to prevent because we're going to prevent aging, so we're going to prevent the next disease that you're going to take. So it's the construct of those diseases that we're going to prevent, and that get indication that would allow us to get much better drugs in the future. So this is what we're trying to do. We're trying to stop this terrible thing that happened now, that we are getting a disease when we're 60 with a treatment that has a side effects, and then a second disease and a third disease with several treatments, with several interactions. It doesn't make sense. We want to start target aging and getting better. So aging has a biology that can be targeted. There's strategies to do that. TAME will attack the regulatory problem, and I'll tell you there's lots of biotechs and pharmaceuticals, and I'm involved in several that are actually setting up companies that have drugs that can target very effectively aging, increase health span, and I think we'll all benefit. So you can think of this song, Time in a Bottle, as what we're doing. Thank you.